This is Alan Trung's video problem presentation for Chapter 9, Question 17 for Physics 114. The problem was, in a Little League baseball game, the 145-gram ball reaches the batter with a speed of 15 meters per second. The batter hits the ball, and it leaves his bat with a speed of 20 meters per second in exactly the opposite direction. The first question was, what is the magnitude of the impulse delivered by the bat to the ball? The second question was, if the bat is in contact with the ball for 1.5 milliseconds, what is the magnitude of the average force exerted by the bat on the ball? As for knowns, the problem shows us that the mass of the ball was 145 grams, which is equivalent to 0.145 kilograms. As for initial velocity, it was 15 meters per second from when the ball went towards the batter. For final velocity, it was negative 20 meters per second due to the batter hitting the ball in the opposite direction. As for time, the time was given to us at the second question, which meant the ball in contact with the bat lasted 1.5 milliseconds, which I converted to 0.0015 seconds. As for unknowns, we do not know J, which is equivalent to energy, and we also want to know what average force was in the question. This is just a picture that I drew. Okay. To find the magnitude of the impulse/energy for the first question, I used this equation, which was J equals final momentum minus initial momentum. To find initial and final momentum, you just need to use the equation momentum equals mass times velocity. We already knew the mass and velocity for both sides. We knew mass was 0.145 kilograms for both initial and final. As for final velocity, it was negative 20 meters per second. For initial, it was 15 meters per second. I calculated both, and I got negative 2.9 minus 2.175. That added up to negative 5.075 newtons times seconds, but we're only looking for magnitude, so I rounded the number to 5.08 and it also became positive. As for the second question, we needed to find the magnitude of the average force exerted. The equation I used was J equals force average times time. To single out average force, I divided both sides by time, moved J divided by T to the right so it looked clearer, and then I just plugged them both in. J we found in the first problem, and time we knew from the beginning. I divided those two numbers, and the final answer was 3,386.66 continued until 7 Newton times seconds, or rounded to 3,386.7 newtons times seconds.